Good day, everyone. Welcome back to our class again. Today, we'd like to look at motion under gravity. Motion under gravity. Now, if you are talking about motion under gravity, then you are talking about motion of the Earth's gravitational force. If I have an object this way and the object is lying on a surface. So this is my surface and this is my object lying on the surface. You realize that there are several ways in which the object can move. There can be an upward movement this way. There can be a movement in this horizontal direction, meaning that there can be horizontal motion and then there can be vertical motion. There can also be motion at certain angles, which we all know from the beginning that you have to resolve this into x component and then y component. That is the vertical and horizontal component. Good. Now, if you want to talk about motion under gravity, then you are talking about vertical motion. So motion under gravity has gotten to do with motion of objects due to the effect motion of objects due to the effect of gravity. And in most cases, then we are talking about vertical motions. So motion under gravity has gotten to do with what an object feels in terms of gravity. So if we have an object moving in a horizontal way or horizontal motion, then it means that that object, even though it experiences gravity, there is no effect on acceleration due to gravity on the object. That is how come anytime we have a body of a certain mass hanging, then we say that the weight is always directly or directed towards downwards, that is towards the center of the earth. So we assume or we take it that every downward motion is a motion towards the center of the earth, and that is what you are going to get with motion under gravity. So motion under gravity is basically talking about the motion of objects with gravity or with what we call gravitational force, and we use G here to represent gravitational force. Now, according to scientists, gravitational force G is equal to 10 meters per second squared. There is a relation that can help us to prove that G is equal to 10 meters per second squared. But as we move on, we can talk about it later. But there is an equation T is equal to 2 pi multiplying square root of L over G, where at the lab you can perform an experiment and make T squared, which is equal to 4 pi squared L over G. So if I want G, G becomes equal to 4 pi squared multiplying L all over T squared. So that when you use what we call the simple pendulum, you can perform an experiment of the pendulum, which is basically a string with a bob. So this is a string with a bob attached to it, so that you count a number of oscillations and record the time for a certain number of oscillations. Then you plot a graph of the length against the period squared. This is a constant, so it counts in later, and then you can use that to find gravity. This is something that we are going to do as we move further in our class. Good. Now, for motion under gravity, we are going to be writing equations or Newton's equations for motion under gravity. Those of us who have been following us or from our previous knowledge, we know that Newton has 3 equations of motion. So Newton, that is Isaac Newton, has 3 equations of motion. So Newton's equations, first one we have V is equal to U plus AT. The second one we have V is equal to S is equal to UT plus half AT squared to represent our second equation. And then the third equation, we have V squared is equal to U squared plus 2AS. Yes, the A there is equal to acceleration. Now, these accelerations are always horizontal accelerations, or sometimes accelerations that are inclined at certain angles. But when you are talking about motion under gravity, then the acceleration A becomes equal to G. Therefore, we can say that from the first equation, V is equal to U plus Gt. So anytime you see J in an equation, then it means that we are talking about the equation in terms of gravity. The second equation too becomes S equal to Ut plus half Gt squared. And then the third equation becomes V squared is equal to U squared plus 2Js. So this is how you can rewrite Newton's equations of motion for motion under gravity. You'd all bear with me that if an object has to do this kind of movement, then let's consider an object being thrown from a certain point. Let me call this point X. It goes up to a point Y. Okay, so if the object goes this is the upward motion, and then from here coming, this is the downward motion. Let me call this point also Z. So from X to Z, we can classify the distance from X to Z as the upward motion, and then we can classify the distance from Z to Y as the downward motion. So if we do these two classifications, you realize that we have already said that gravity is always acting downwards. So let me just add that equation J. What it means is that any motion that is coming downward is coming or is doing so with gravity, and therefore for downward motion we can say that gravity is positive, but for upward motion we can say that gravity is negative due to the direction of motion that we have. And therefore, if we want to write equations of motion for upward motion, then the first equation of motion for upward motion, since the body is moving against gravity, is going to be V is equal to U minus, or let me say plus, into bracket negative Gt. So that this becomes V is equal to U minus Gt. Equation 1. Our second equation becomes S is equal to Ut minus half Gt squared. Equation 2. Our third equation becomes V squared is equal to U squared minus 2Gs. This becomes our third equation. The same equations can be written for downward motion. So that for downward motion, since gravity is always acting downwards,